This is the GAIN data landing page, which displays our current data partners, their subject and variable counts, and on-offline status. Our main tool is the Interrogator, which you can access after creating a free account. In the Interrogator, you can see that our data partners are grouped into longitudinal and cross-sectional datasets. We recently updated this layout so that you can now sort data partners by name, country where their subjects are from, number of subjects, number of variables, and last updated dates. Our search function is still available on the top right of the screen. For this demonstration, let's say I'm interested in CSF fluid biomarkers, so you can search for CSF across all data partners. In the results, you'll see that some correspond to CSF volume, while others correspond to CSF biomarkers. So make a note of the ones that have CSF biomarker data. Let's say I'm also interested in the Functional Activities Questionnaire, or FAQ, so you can search for this as well. And now I will pull the datasets that have both CSF biomarker and FAQ data, which ended up being ADNI, the Alzheimer's Disease Neuroimaging Initiative, ADNI Department of Defense Study on Vietnam War Veterans, and ADNI Argentina. Click Create and name this pooled dataset. Now inside your pooled analysis, you can uncollapse each data partner to see all the variables they've made available on GAIN, or use the search function to narrow down your variables of interest. So I'm searching for CSF again, and now all variables that have CSF in the name or description will show up. First, let's look at CSF amyloid beta 42, which is a numerical variable, so it displays a histogram in each data partner. In the description for ADNI Argentina, it says that pathological levels of Aβ42 is lower than 534 picograms per milliliter, so we can use that as our cutoff. Click on Map to a pooled variable and select Map to 0 or 1 under New Pooled Variable. So lower CSF Aβ42 values are pathological, so that is going to be defined as 1. And you can specify the range division in the text box below. You can set any value as your cutoff, so if a cutoff is not provided in the description, you can use what is accepted in literature or based on subject counts such as median or top-bottom quartiles. Click on Create and name this variable. I recommend including the value you set as your cutoff in the variable name so you can remember this when pulling other variables. Back to the Data Partners tab, you can do the same for the other Aβ42 variables. Click on Map to a pooled variable and this time select the variable you just defined. Be sure to choose the same cutoff and same direction, as in lower than 534 is 1. Click on Done and go back to the last data partner. Click on Map to a pooled variable and choose the same Aβ42 variable. For this data partner, there seems to be quite a few subjects with a near zero value, which we can exclude with these two bars. For the first division, set this to 100 and exclude those lower than 100. The next division we can set to 534, and so those between 100 and 534 are 1, and over 534 is 0. So using these two bars allows for greater flexibility when defining numerical variables. So for example, by excluding outliers, or if you're only interested in a middle range. Click on Done, and now this variable will say that it has 3 data partners, so we are done with it for now. Next, we will look at CSF phosphorylated tau, and the most commonly measured is at position 181, but if there are multiple phospho-tau variables, you would need to pull the ones at the same position. For CSF phospho-tau, it says that higher than 42.4 is pathological. Here I am running down to 42 and everything higher is 1. Click on Create and name this P-Tau greater than 42. And now I'm repeating the steps for P-Tau with the other data partners. We have two independent variables now, and we need an outcome variable. For example, you can look at cognitive outcome variables such as diagnosis or MMSE scores. Here I'm interested in functional impairment as quantified by the Functional Activities Questionnaire. The domains include finances, filling out forms and records, shopping, and etc. And each question rates the participant's level of dependence on the activity. The total score is 30, and a score of 9 or higher indicates functional impairment. So we can map this to a pooled variable, select new 0 or 1, and higher scores are 1. For numerical variables that have integer values, the divisions are set at 0.5 increments. So choose 8.5 to include 9 and higher. If you don't want to include 9, you can set the cutoff at 9.5. Now we can repeat the same for the other data partners. Now that we have our independent and dependent variables, we can also create a stratification variable so you can compare how the independent variables associate with the dependent variables in two different cohorts. For example, male and female. So you can find a gender or sex variable in these data sets, and this time map to my values. My values are categorical variables with your own definitions. For example, male and female. And remember, the ADNI DoD dataset is a Vietnam War veteran, so that's why it's mostly male. Click on Create and name this variable. Next, do the same for ADNI. Make sure to type the labels the same way so that those participants can be grouped together. And do the same for the last data partner. With our outcome and stratification variables, we can create 4 cohorts. The first cohort will have FAQ less than 9 and is female, so choose 0 for the FAQ variable. Name this. And with the variable still selected, go to the sex variable and select female. Click on Add Condition, and now you can close out of this cohort. We'll also create a FAQ less than 9 and male cohort. And then also FAQ greater than or equal to 9, female and male cohorts. You can also check the age range of this entire combined dataset. And because the age range is between 50 and just over 90, we don't need to narrow down the age range. Next, in the Analyze tab, you have 4 options for analyses: Logistic Regression, Linear Regression, Cox Regression for longitudinal datasets, and Mental hands-on meta-analysis for pooled datasets. In this example, we will use Logistic Regression. You can click and drag your control and case cohorts. In this example, control is normal function with FAQ less than 9, and case is impaired function with FAQ greater than or equal to 9. Make sure your control and case cohorts are both female and later on both male. Click and drag your independent variable, which immediately shows you the subject counts for each condition. Click on Add Logistic Analysis to set up your male control and case cohorts, and add the independent variable here as well. When you have 2 or more analyses, you're asked to name each one. So the first is female and the second is male. Click on Run Analysis. You will see the odds ratios results right away, and we see a drastic difference between female and male cohorts in pathological levels of Aβ42 associating with functional impairment, with the female OR around 8 and the male OR around 3. The arrow bars indicate the 95% confidence interval. You can go back to your analysis and add your p-tau variable. We can compare ORs between male and female cohorts, as well as between biomarkers. Click on Run Analysis. Now we have 3 sets of ORs. The ORs for Aβ are slightly lower than before because now the model is adjusting for p-tau as well. You can hover over each point to see the exact odds ratio, and it's also listed in the chart below. The p-tau male and female ORs are just above 1, so we can say that in this data set, pathological levels of CSF Aβ42 are more strongly correlated with functional impairment than pathological levels of p-Tau181, and this effect is stronger in female than in male participants. When you run an analysis for the first time, you'll see these terms of use, which indicate that the results you see here are for preliminary analyses only and not for direct publication. If you want to report on these results, you would have to request full dataset access from the data partners and run a full analysis adjusting for confounding variables. We do not provide the detailed analysis methods that are required for manuscripts, and the graphs you see here are not customizable. If you publish results using data discovered on GAIN, you will need to acknowledge GAIN and each individual data partner in your manuscript. Lastly, you can save your pooled analysis by clicking on the Save icon on the top left, so you can revisit your variables and cohorts next time. If you don't save, then this pooled analysis is cleared when you log out. You can also save the way your analysis was set up by clicking on the Save icon next to the Run Analysis button. You can access your previously saved datasets under My Pooled Datasets and Analyses under the Analyses tab. To request full data access, you can click on the Apply links below each data partner on the GAIN Data landing page, and you can follow each institute's data sharing policies from there. If you have any questions or would like to learn more about how to contribute your data to GAIN and the research community, please contact info@gain.org.